Let's look at the next tool, Docker. What is Docker? Docker is an open source platform that automates application deployment, scaling, and management within containers. Containers allow a developer to package an application with all its parts, such as libraries and other dependencies, and ship it out as one package. This ensures that the application will run on any other Linux machine regardless of any customized settings that the machine might have that could differ from the machine used for writing and testing the code. Docker uses a client-server architecture with a Docker daemon running on the host machine and the client talking to the daemon to manage containers. Docker images, which are lightweight, standalone, executable software packages that include everything needed to run an application code, runtime, libraries, environment variables, and config files, are used to create Docker containers. These images are stored in Docker registries such as Docker Hub, allowing users to share and distribute containerized applications more efficiently. Overall, Docker simplifies the development lifecycle by managing the intricacies of the environment where the applications run, making development, testing, and deployment processes more predictable and efficient. What to expect in the Docker interview? Preparing for an advanced Docker interview requires a deep understanding of containerization principles, architecture, and practical experience with Docker environments. You'll need to demonstrate proficiency in creating efficient, secure, and scalable Docker solutions. 1. Docker fundamentals. Containerization versus virtualization. Understand container differences, benefits, and limitations compared to traditional virtual machines. Docker architecture. Be familiar with the Docker daemon, Docker client, images, containers, Docker Hub, and Dockerfile. Understand how these components interact within the Docker ecosystem. 2. Docker images and containers. Dockerfile best practices. Know how to write efficient Docker files, including minimizing layer size, ordering instructions for cache optimization, and using multi-stage builds to reduce final image size. Image management. Understand how to manage Docker images, including tagging, pushing to and pulling from registries, and optimizing image storage and layers. Container lifecycle management. Be adept at starting, stopping, pausing, and removing containers, as well as managing container states and logs. 3. Docker networking. Networking models. Understand Docker's networking capabilities, including bridge, host, overlay, and MAC VLAN networks. Be able to configure and troubleshoot container networking. Port mapping and communication. Know how to expose container ports to the host and enable communication between containers across different networks. 4. Docker storage and volumes. Persistent storage. Understand the importance of persistent storage for stateful applications and how to implement it using Docker volumes and bind mouths. Storage drivers. Be familiar with different storage drivers Docker supports and how to choose the right one based on performance and compatibility requirements. 5. Docker Compose. Orchestration with Docker Compose. Know how to use Docker Compose to define and run multi-container Docker applications. Understand the structure and options available in a Docker Compose YAML file. Best practices. Discuss best practices for Docker Compose, including managing environment-specific configurations and secrets. 6. Docker Swarm. Cluster management. Understand how to set up and manage a Docker Swarm cluster for container orchestration. Services and stacks. Be able to deploy and manage services in a swarm, scale them up or down, and use stacks to manage multi-service applications. 6. Security in Docker. Container security. Know the security implications of containerization and Docker. Understand how to secure Docker containers and images, including using non-root users, scanning images for vulnerabilities, and using Docker Bench for security. Network security. Discuss strategies for securing container networks and implementing network policies. 7. Performance optimization. Monitoring and logging. Be familiar with tools and strategies for monitoring Docker containers and hosts, including logging best practices and using Docker native tools or third-party solutions. Resource limits. Understand how to limit container resources using CPU and memory constraints to ensure optimal container performance and resource sharing. 8. CI/CD integration. Docker and CI/CD pipelines. Discuss how Docker can be integrated into CI/CD pipelines for building, testing, and deploying applications. Be familiar with tools and platforms that offer native Docker support. 9. Advanced topics and trends. Kubernetes versus Docker Swarm. Understand the differences and use cases for Kubernetes and Docker Swarm for container orchestration. Emerging technologies. Stay informed about emerging technologies and trends in the Docker and container ecosystem, such as Containered and BuildKit. In addition to mastering these topics, be prepared to discuss real-world scenarios where you've applied Docker to solve complex problems, optimize workflows, or improve system architecture. Demonstrating a blend of theoretical knowledge and practical experience will be key to standing out in an advanced Docker interview. Thank you everyone for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview. You can find the link in the description below.